Module 7, Lesson 3 covers graphs of relationships. The content objective says students will write equations and graph lines to represent the relationships, and the pacing guide says this one's going to be a single day lesson. Shouldn't take long at all for us to get through it. Relationships can be graphed to visually represent the information. It is often easier to recognize and understand trends in a relationship when it is graphed. For example, a bank might use a line graph to show mortgage rates over time, or a retail store might display their sales using a line graph. Why do you think displaying a relationship on a graph might make it easier to recognize trends than displaying the relationship in a table? Well, the line graphs are really great visual representation. You can really see patterns easily that might not jump out at you when you're just staring at a whole bunch of random numbers on a sheet of paper. Now you can use an equation that represents a relationship between an independent variable, also known as your input, and the dependent variable, also known as your output, to graph the relationship on a coordinate plane. The independent variable is always going to represent your x coordinate. Your dependent variable is always going to represent your y coordinate. Similar to graphing ratio tables, you can make a table of values to represent an equation using the table to generate a set of ordered pairs, and then graphing the relationship. So we're going to select some buttons here to see how they would end up graphing y is equal to 2x plus 500. So first thing on the table, where x was 0, y was 500. Where x was 1, y was going to be 502. Where x was 2, y is 504. And where x is 3, y is 506. Now, I don't really like the fact they're using such massive numbers here because it's going to kind of skew the graph a little bit, but let's see how they ended up doing it. Next, we're going to look at the ordered pairs. Your ordered pair is always written with a parentheses and a comma. So, for example, your first ordered pair was parentheses, 0, comma, space, 500, and then close parentheses. I find a lot of students forget to put that space in there when they're writing an ordered pair electronically, and because of that, they miss the question. Now, keeping it going, the next ordered pair was open parentheses, 1, comma, space, 502, and close parentheses. And the pattern continues on from there. And from here, we're going to graph it. Now, I want to point out that this is what we call a broken bar graph, or a broken graph, not because it doesn't work, it's not that kind of broke, but because there is a break in it. That first jump, they went from 0, bloop, all the way up to 500, and that's a huge jump. And then after that, it's 502, 504, 506, and so on. So this break allows you to take and do that. Otherwise, you'd have a long way to go on that graph getting 0 to 500 if you're counting by twos. See why you need a break there? I could use a break right now. From there, the first ordered pair was 0, 500. Superman ran 0. He flew to 500. The second ordered pair was 1, 502. Superman ran to 1. He flew to 502. Your third ordered pair, 2, 504. Superman ran to 2, flew to 504, and then your last one is going to be 3, 506. Superman ran to 3, and he flew to 506. So here we have our data as a table, we have our data as a set of ordered pairs, and we have our data as a graph. And I should add that all of that data came from this original equation, y is equal to 2x plus 500. So we're actually representing that information 4 different ways. Let's keep moving forward with example 1. The graph of A is equal to 126 times B represents the approximate number of apples A in a bushel of apples. Bushel is something that looks kind of like that right there. It is a way that they measure produce when they collect it. What is the dependent variable? Well, your dependent variable is going to be the number of bushels, and the independent variable, that's going to be the number of apples, because you're multiplying the apples Actually, I said that wrong. Your bushels are going to be your independent variable, and your apples are going to be your dependent variable, because you're multiplying the bushels B times your number of apples, and times your number of apples that are in the bushel, which is 126, and that is going to give you your output, which is A, the number of apples that are totally collected. So with that information, you should be able to answer these questions. Remember, if you can always go back and look at the problem if you need to. The number being multiplied by the variable, well, that variable bushels, that's going to be your independent variable. So we're going to put it right here, and then your output here is going to be A. A is going to be your dependent variable. Check it, and it checks. Next, we're going to take and use that equation, A is equal to 126 times B, to come up with the information to fill our table. Well, 0 times 126, that's going to be 0. Because think about it, if you have 0 bushels of apples, how many apples do you have? You have 0. Next, 1 times 126, that's going to be 126. 2 times 126, that's going to be 252. I do believe. Did that right in my head? Yep, excellent. So now we have some information to start off with filling in our table. After we make our table, then I'm thinking it's probably going to be time to select some ordered pairs. So to create our ordered pairs, the first ordered pair is going to be parentheses 0, comma, space 0. Your next ordered pair is going to be 1, comma, space 126. And your last ordered pair is going to be 2, comma, space 252. And of course, being ordered pairs, all of those have to be in parentheses, because that is what we call a clue in math, that we're dealing with ordered pairs. Check your answers, and it all checks correct. Moving forward, because we cannot have partial apples, think about it. Do you really want to have an apple in your bushel? The line representing the relationship should be a dashed line. So we're going to be using a dashed line here instead of using a solid line, because there's going to be partial apples, not whole apples. And from here we need to take and graph the numbers that we've got. So I'm going to take and activate my point. First point is going to be at point 0, 0. That's going to go right there. The second point is going to be at 126, which is going to be right there. And our third point, well, that's going to take place at 252, which is almost, wait a minute, would not go that high? No, I can't see it. Let me zoom in here for a little bit. Whoop, not quite that much, that's a little crazy. 251, I think that was 252 right there. And then they do also need to connect them with a line. So we're going to be using a dashed line here, and we're going to take and put one point maybe right down here. And we'll take that other point and we're going to put it right up there. And we should be able to check our answer. It's correct. It's just not quite lined up right because of how the graph works, but it's going to be very, very close. Your graph should look like that as well. Now it's going to be your turn. You have the equation C is equal to 3B divided, plus 2. That's a plus 2 right there. So first thing you're going to need to do, create your table based off your information. After you have your table, create your ordered pairs. After you have your ordered pairs, then you need to graph your ordered pairs and check it. Go ahead and pause the video while you do all this. Now this is where we're going to end part 1 of this video. When we come back, we're going to work on part 2, where we're going to learn to write an equation from a graph. Last time we created a graph from an equation. Now we have the graph. We had to come up with an equation to match it.